done. And the concept of a receiving parameter, it's just to make things look slightly more comfortable for someone who says, oh yes, this I understand. You can understand the meaning of this. This is nothing but the receiving object. The type is rectangle anyway because these are methods on rectangle object. So in any of these methods, I could here also, if you want, I can add that also. I can say any of the methods. I can say this. This here is a keyword. It doesn't. It's not mandatory to write. Okay. Earlier, it was not allowed to be written like this. So from Java 10 onwards, yes, you could be specifying a receiving parameter for a method for a better understanding. Just for a better understanding. Otherwise, how do I say what is width? I don't have anything like width. Okay, it is this property. Okay. So your methods always have a first parameter which was always being hidden earlier. It wasn't explicitly to be mentioned, and it wasn't allowed to be mentioned. But if you want, from Java 10 onwards, you can explicitly mention that yes, my methods are working on an object, and the object is available as this. This method works on an object, and that object is available as this. Fine. So we've got two kinds of things so far in a class definition. A class can have instance variables. A class can have methods. Okay. Now looking at the test rectangle, we find that how is the object of rectangle created? By saying new, and you're not passing any values. Okay, fine. Someone would like to say, no, I don't want it this way. If you are creating a rectangle object, if I want to allow someone to create a rectangle object, I don't want someone to just create a rectangle object just like that. Fine. It should be something like this should work. We should say, oh, R1 equals new rectangle, and I should be able to specify two values for the length and width. This is what I am designing, or that's what we are designing for. I want to have that if someone is wanting to create a rectangle object, that time itself we should be giving the length and width. Every rectangle has a length and width. Right? When I was in line 23 here, if you are creating a new rectangle object, you are not specifying any values, and therefore it is initializing the length and width as 0. Okay, right? But we want this thing to work for us. We want this to work. Okay, in that case, we can add constructor, what is known as a constructor, to our class definition. A constructor is returned by using the class. Okay, so someone can create a rectangle, fine, and say, okay, so this is similar to a method, but the difference here is we will not be specifying a return type. Constructors do not have a return type. Okay, fine. They will have parameter. Here also, like methods, you can have receiving parameter also. You may mention a receiving parameter. Fine. You may mention a receiving parameter. I am not writing a receiving parameter, but if someone wanted, yes, you could say writing like this. So constructors also can have the first parameter as a receiving parameter. So let's do it the normal way. It's like this. I can say, okay, in length, or not in width, So two parameters in my constructor. So this is nothing but a okay. So we have a constructor, and the constructor takes as parameter length and width. Okay, and now what can be done? Yeah, what do we do here? One option is yes, we could just say this, that's the object on which the method is invoked, on which the object which is being created. Now here in a rectangle, it's a constructor. So constructor means an object is getting allocated. So the constructor is used as soon as the object is allocated. So this dot length is equal to length. Yeah. Okay. Fine. So I assign the first parameter in the constructor to, okay, how is this going to be invoked? It's a constructor, but how is a constructor invoked? Okay, for example, in this case, it's a new rectangle, and you will be giving two integer values, right? So some int, okay, and another int expression. That's how you will be calling it. So constructors, this is fine. I'm just writing how it's going to be used here. Okay. Right? So if you are writing a constructor, the usage will be with the help of new. The application will have to say new and give two integers here. Okay. So you might do like this, or someone could do another way. We already have a method called setDimensions, and here you say this was setDimensions, and then the width will be passed. Okay, I'm writing it like this by saying this one, right? So I'm again using what was already done in setDimensions. Okay. Fine. I just put it in comment. What was the other option here? Other option was to say this set dimensions. Okay. And then, okay. So that's the other option you have. Okay. But instead of using this option, I'm again doing explicitly the same thing which is done from the set dimensions now. Okay. Fine. So constructor. Now let's see what happens when we compile this code. Okay, we have written a constructor here, and here we are saying okay, r1 dot r1 equals new rectangle. That's a place where we are using the constructor. When we call a constructor to create a new object. So what we use with new is nothing but invoking a constructor. So what is done when we let's say new rectangle 7th time? It first allocates a space for the length and width, and then uses the code of the constructor on that object. Okay. See the difference between method and rectangle and the constructor. What's the difference? Constructor is used only initially on the object. As soon as it is allocated, it's always used with new. Means allocate and this is what is done. Whereas methods are used after it has been allocated. Once you have an object created, then on that object you can keep on invoking any method any number of times. Constructor was called only once initially when it was created, only at the time of creation. Check what happens now. Does it compile? It's giving an error. And where is the error? Oh, the error is in the line where you have, when the lines which we had put earlier, which was compiling earlier, is now fading. Okay. And what we had defined, we were using new rectangle and we didn't give any parameters to it. This was working earlier for me, but it has stopped working now. The reason here is every class always has at least one constraint. Okay. Fine. All classes will always have at least one constraint. If you don't put a constructor in a class definition, which was the case earlier, okay, fine. If you don't put a constructor in a class definition, then by default, the compiler would add a constructor into the class. Okay. If you want to understand, it is something like this. Right? Prior to this constructor being added, what was being done by the compiler, though we had not put this code, the compiler was adding this kind of a thing. It was putting this. And it was like this. There was no code in this. It wasn't doing anything. So you by default had a constructor which would use no parameters. And not putting any constructor at all, it finds the compiler says, oh, I don't see a constructor. That means I need to put this constructor. Okay. So if you don't have a constructor, that's one no argument constructor which is defined for us by the compiler. Compiler would add this. Okay, and that's why the earlier code was working. But now, when we have defined this constructor over here, okay, so compiler finds that there is already some constructor, so it will not have to add a constructor. Every class needs at least one constructor. Okay, since we have added this, yes, compiler is not adding a constructor. Okay, so fine. Now we understand why that thing has stopped compiling. Okay, so this would not compile. So let's comment it out. Okay, so fine. We have created a new rectangle R1. Okay, same way we might also create another rectangle for R2 and with different dimensions. Let that be something like 8 by 3. We have printed length and width of R1, and I think we are printing for R2 also. Okay, let's combine. First thing, yes, it should get combined now. Oops, sorry. Yeah. So we compile the code and run it. Okay. So yeah, we have changed that. Width is 6. Okay. Yeah, that is fine. After the second, oh, what have we done for the constructor? We specified 6 for the constructor. Achha, 7 by 6. Oh, set dimensions is done 7 by 6. Okay, oh, we may comment it out. Right? We can comment this because now our object is with some initial values for the element. Okay. And this is creating 7 by 5. Okay. Okay, fine. Okay, so let's move on with the next things in the class definition. Okay, now we have got a set dimensions method already in our class definition, fine, which can set the dimensions for the given length and width. Okay, now someone says, okay, I should also be able, I would like to have another set dimensions method. Okay, where I give only one integer value for the side. Okay, I want both the sides to be the same value. So if the idea here is if I give only one value with set dimensions, I mean to say, okay, this is the value for both the things, length and width. Okay, fine. So how can this be done? I just simply say this dot set dimensions side and set. It's just invoking the earlier method, right? There is a set dimensions which takes two parameters. I am now creating a set dimensions which is taking only one parameter. So this thing where for the same method we have got two signatures where one where it takes two parameters and other takes only one parameter. Okay. This is known as method overloading. Okay. So we are overloading the set dimensions method. Okay, what we have done here is we have overloaded the set dimensions method. Okay. Same way, we may also overload the constructor. So, like we have said, a method being overloaded, even constructors can be overloaded. So, you can have a constructor which says, okay, I'll take only one value, and now from this constructor, I would like to use the previous constructor. Right? I just want to use the earlier constructor, the constructor with two parameters. Given one parameter, I'll invoke that other earlier constructor with both parameters same. Okay. So yeah, how do I invoke the constructor? No, you can't be saying new. If I say new, then it means suppose someone writes like this. What would it mean? This is simply allocating a new object. Okay, from a constructor, just say, oh, let me allocate another object. See, this is already this is invoked when the allocation is already taken place. A constructor is getting invoked as the first method on a allocated object. So we are not interested in allocating one more object from here. Okay. Also, so because of new, yes, it's calling this. Also, you don't use the class name. Instead of this, you have to use the keyword this. The use of keyword this is also done in a constructor to invoke another constructor. When you have overloading of constructor, this is constructor overloading because a different method signature, a different set of parameters, but allowing you to create objects. Okay, so you can create object by using single parameter or one parameter. Okay. So this is nothing but so this will allow someone to use. Okay. So this allows someone to use constructor with one parameter. right? So it will be used, someone will be able to say new rectangle and pass only one integer value. Okay, and that's what this is going to allow now. So both things are allowed. Okay, you may pass one value or you might pass two values. Okay, this is the other thing which we have seen here is the use of the keyword this. In a constructor, you can invoke another constructor, not for allocating another object, because already when it's in the constructor line 28, okay, the allocation of a new object has taken place, and this is the code to be used. So when I'm calling this here, it's more like I'm invoking this kind of the other constructor as if it's some kind of a method. Okay, this is being used like a method. Okay, fine. But that can only be done from a constructor. Another thing to remember, when we use this to invoke a constructor, right, it can only, you can't do this from a method, right? This and a list of parameters cannot be used from a method. It can only be used from a constructor to invoke another constructor. Okay? And when it is used, it has to be the first statement in the constructor. It has to be the first statement of the constructor. I can't have some other valid code here. Okay, I can't say okay, side, or someone says, oh, let me print the value of the side. Okay, if someone writes like this, then this is not valid. Okay, if you are using this kind of a thing, it should be the first statement only. Okay, you can see what happens. Let's compile. Okay, and what's it? Call to this must be the first statement in constructor. Yeah. So you can have it later. So no statement can precede a call to the constructor from a constructor if you are invoking a constructor. Okay, so this is invoking another constructor from a constructor of the same class. The keyword this is used. Okay. So what can go in a class definition? If you just go back, what are the things which go in a various kinds of things which go in a class definition? Length and width define the structure. Okay, we can have methods. Okay, like area is a method, get length, get width, set dimensions. Right, these are methods. We can overload method and set dimensions. Here is an overloaded method. Okay, we can have constructors. And we can have a constructor, and we can also overload a constructor. Okay. And when we have overloaded constructor, we may be able to use another constructor by using this. So we can invoke another constructor from a constructor by using this. Fine. Clear what we have seen so far? Okay. Okay, what we haven't done here is, okay, what we can do now here is, okay, we have created 8 by 3, R2 equals 8 by 3. Oh, we have one more variable, R3 also, right? Let's use that R3 equals new, and we can just use a variable like, okay, let me have it by, it will be a 9 by 9. So I am using the other constructor here. See, before test rectangle, that's our class definition, right? We are trying to see what all we can do and how we can use this kind of a definition. the meaning of each of those things which is going in a class document. Well, we're just trying to use it in different ways. What is the effect of the various members which is there? Okay. But I put it in the same file so that you can see it simultaneously at this place. We could have defined the other class for test rectangle in a separate file also. Okay. And normally, yes, we do it that way. We have a separate class in a separate file. So we could have created a test rectangle.java file, put the test rectangle there. Okay, this is just a convenience. I don't have to switch between two files. Okay, and that convenience is there so far as I am not defining the class to be public. Okay. If I want to have this as a public class, we understand we have to have a file named test rectangle.java. Okay, so overloading of constructor is also done. Now the next step. See, we have this method called set dimensions, or we have this method called area. All of these are methods which can be used on an object only. We can't say rectangle dot set dimensions. We can't say rectangle dot area. None of those methods can be used without an object. All of these methods have a target object, right? Without object, I can't use area. Without object, I can't use any of such methods. Whatever we have put so far, they are all related to an object. They are not without an object. But sometimes I might like to add things which has no relation with the object, which do not interact with the object. Okay, they may not be required to have an object here. So, for example, maybe I would like to say that. Okay, fine. Now it's not related to any specific object of the class, but I would like to say that yes, for the objects of the class rectangle, I am interested in maintaining how many objects of rectangle are created. I want to keep a count. How many times have I called the constructor? Right? How many times have I called the constructor so far? Right? So can this be done in a rectangle class? I want to have a mechanism to keep track of how many times the constructor has been invoked. So you might use something like saying, okay, you may be having a tendency to say, oh, let me have a variable for count. And when we are writing the constructor here, I just say, okay, here is a constructor being invoked. Right? Whenever a constructor is invoked, I would just like to say count plus plus. Right? So I am counting how many rectangles have been created so far. Each time a constructor is called, the count is going to be incremented by 1. Because see, the second constructor, even when this is called, it's going to invoke the earlier constructor, count will be incremented. So you might be saying new rectangle with 1 integer, or you might be saying new rectangle with 2 integer. In both cases, this will be executed. Count is going to be incremented by 1. So whatever way you create an object, I want count to be incremented. Okay, is there any problem with this? Okay, let's try to see it through a figure. Fine, let me show it in. Fine. Let's try to check it out here, how it will be done. Fine, what's going on here? Right? Let's see. Fine. Now, What according to the new definition which we have for the rectangle class, right, we have got length and width being defined. Okay. So we have defined okay, um, okay. So we have defined a so if we allocate an object of rectangle space for three things will be there, right? Each rectangle object has a length, a width, and now let's say, oh, I want to have a count also. I want to keep count of how many times the constructor is called. So yes, we have the count also here, right? And all three initially set to 0. Okay, they're initially set to 0, and then the constructor is called. When the code of the constructor will be called, so if you are saying new rectangle 75, right, what will you do? Initialize this to 7. It was 0, but it would be made as 7. This one will be made as 5. And oh, while it is doing this, it's also done one more thing. It has said count plus plus. So this count from 0 will become 1. Okay, that's the first object created. Count is 1. Okay. Then it says, oh, let's create a new object. One more object. So it allocates another space. It would have its own length, width, and a count. Oh, all three were 0. The constructor code is called. It is called with 8, 3. So this will be set to 8, this will be set to 3, and what happens here? It's a separate count, and this is the count which is being updated from 0 to 1. So what will be happening is, you don't have a count which is incrementing. It's not a common value across all of them. It's not a common value. Right? So count cannot be declared the way we have declared currently. We don't want count to be part of the object. No, this is a wrong idea. We don't want an instance variable. Count cannot be an instance variable. Count has to be at some place, which is a single value only. Fine. See, now understand one more thing here. I'm just introducing one more concept. Okay. For every class which we are defining, or we have defined a class called rectangle. Fine. What the code has to do when we execute that main method, it has to load the class definition. The compiled rectangle.class which is there, that has to be loaded into memory first. Okay. So when it is loaded, we have a place where the definition of the rectangle class is available. There's no rectangle object created yet. Fine. There is a definition of the rectangle class where it has all the information that yes, the rectangle class has two instance variables, and whatever we have defined, that code, the rectangle class which we have defined, that's going to be loaded. Okay, so this will be loaded only once. A class is going to be loaded only once. I have this definition of the rectangle class, and then I'm using a constructor, I'm using various things. They are going to be checked from here. When someone has to allocate a new object, it checks, oh, there are two instance variables, or whatever the number of instance variables, I have to allocate the space for them. So at one place, there is one place where the definition of my class is being loaded, and it's a space is allocated where it keeps the definition of my rectangle class. Okay, so that's a good place where I can, if I can manage a count object over here, a count value over here, because that's only one for my class definition. My class definition is only one, it's not multiple. You may have 0 objects, you may have 1 object, any number of objects you may have. My class has been loaded, there's one place for that. So in this place, can I manage some variable over here? Can I ask it to keep space for my count here? And yes, that can be done by using the word static. So if you make your variable to be static, right? You can declare a variable to be static. Then it doesn't require an object. It's not working on an object. Okay? And it doesn't depend on an object being allocated. You may not have allocated an object, but count is there. As soon as the class is loaded, fine. When the class is loaded, just space for count should be allocated, and that is what can be done by declaring that variable to be static. Okay. So you can have here. So here, when we have declared count, we say this is a static variable. Static variable means, okay, fine, only one copy. Okay, not related to it's not related to the instance of the class, and no dependence on object creation. Okay. Those were part of the object, right? Instance variable, part of every object. And every object has its copyright. Right? A separate copy for each object. Whereas this has nothing to do with the object. Okay? And so, yeah, so this is one thing. So now the question here is, how do I access count? Right? How do we access count? So here then comes the class name. Okay, the proper way to access count would be, oh, I have not even created an object, and I can say, let me print I want to print the count, and just say rectangle.count. Okay. So I can call rectangle, let me print the value of rectangle.count. You can print rectangle.count here, 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 after creating each time. Okay, and so we are just printing the value of count. Okay, I think we should have a message that says count is plus. Okay, I can replace it with. Okay. Okay. So yesterday I think we have finished with the initial understanding, some introduction to the use of operators and statements, and then we just started to look at. We just started to look at the what is a class, and we would like to understand about a class. Fine. Using class as a data type. Fine. Okay. So, any questions so far? Yeah. Okay. Fine. So we'll proceed. Okay. Fine. So the main idea here is to understand what goes in a class definition. What are the possible things which can go in a class definition? When we have seen that yes, to define a class, we just use a keyword class, put a name of a class, and then within the body, yes, there will be various members which will go. Okay, fine. And then simultaneously, it's not about just we'll try to understand how to use this class. Okay, so we are writing two classes here. One class is a class called rectangle. That is the one where we would like to study what all things can go in a class definition. And the other class, we are calling it as a test rectangle, is just simply a placeholder for our application. It just has an application which will try to use the rectangle class. Okay, and we'll see what are the various things which we can do as we keep on adding more members into a rectangle class. So what can be done with a class? Fine. How the various members go, what is the meaning of each of those members? Fine. We are trying to understand that. Okay, fine. So I think that yesterday there was some problem, fine, towards the later part where you could not, I think that there was some network issue, so it got disconnected, right? Okay, for some time. And okay, so fine. So just let's review what was done. So we created a class called rectangle. Initially it was without anything, and then we saw how it can be used. So one is, yes, we can declare variables, right? So okay, here is our class definition. Okay, then that is our class definition, and here in the main method we are saying how it can be used. Okay, so a class, when you define a class, it's a data type, right? So with any data type you can declare variables. Okay, so that's what is the first thing. Yes, in this line, okay, we have just simply declared variables, just like, okay, so rectangle is a data type and we have variables for a type. Okay, R1, R2, R3, we just declared the variables. Okay, the next line is showing that yes, if there is a class, okay, you may like to create an object of that class, right? So here is how you may be creating object of a class, right? So when you create object, yes, it will have to be referred from some place. Okay, right? So we have a reference variable R1 and we are initializing it and we are saying, okay, from R1 let it refer to the object which we are creating. Okay, so this new rectangle in this line, okay, line 10, the new rectangle is just simply saying create an object, and R1 is a variable which will hold the reference to that object. Okay, fine. The next line is again about the second variable getting initialized to another object. So R1, R2 are two distinct objects. Okay. Fine. There are two objects which we have created. We have used new twice. That means we are creating two objects. Okay. And then next line. Yes, I think we have commented it out. Okay. The line 12, which is a comment, it simply shows that yes, someone might think in that manner that, oh, we have a class called rectangle and length and width, they are variables, they are members of that class. And therefore someone will say, oh, let me try to access rectangle.length. No, that is not legal. Right? So it's not rectangle.length. Length is an instance variable, width is an instance variable. Okay, instance variables cannot be used just like that. You will have to have some of. So you can see count is 0, 1, 2, right? As we call the constructor, yes, initially there was no object and then we had two objects, and later it became 3 also, right? So 3 objects were allocated, that's what we can see. Yeah. So static, the meaning of static is in a class definition, in this class, in any class definition, okay, everything is about object. They all depend on object, but as soon as you use the word static, You are not talking about the object. Anything static means it has nothing to do with the object of this class. Okay. See, we have also used static here. We have a method which is static. Oh, we never create object of the test rectangle class. The object of test rectangle class is never created to use the main method. It is only simply loading the test rectangle class definition. Fine. Yeah. Oh, we had that other class called Hello World. Right? We have also got that. Oh, it is con dot. You want to invoke that Hello World from here? Hmm. It's a static method there, and therefore I should be able to say, oh, what was the package name for Hello World? Let's see what's the package name for Hello World. Um, because we had made it part of the package, right? Let's see. Recollect this a prefix called class of Java first time. Okay. So if you want, what we could do here is we could say, and back to this place, and here, if you want, we can just say, okay, com dot class of Java dot. Okay, there will be some problems I think because we haven't made things public there. Yeah. Oh, it's not a public class. So anyway, this would create an error. And but name, and I can pass a string array. Args here is my string array, so I can invoke. I can try to invoke like this. Okay, this would have a compilation error. It's not a public class. We haven't talked about public things. Yes. Package from okay. Let's see. Okay. While compiling, I'll have to invoke. Here also, I'll have to specify that the compiled class is in bin package. So, like minus d I have given, I can here also I can say minus c because I have the compiled class for this is compiled. Okay. Now the error is sorry, it's still saying not exist. Yeah. Okay. Fine. So com dot class of Java dot first line. This is com dot class of Java dot first line. See, the error is here. Let me show you where the error has come. What's the mistake we have made? By invoking the main, well, we just give the main, we didn't say hello world, right? That's a class name. It's hello world document. Well, that was only the package name, but we have to say class name dot static variable or static method, right? So class name is this full class name. So we made a mistake here. Fine. But we'll still have an error. No. So we haven't written a code which will not be without the error. But look at the error. Now what is the error? Hello world is not public. And therefore it cannot be accessed from the unnamed package, right? Fine. But the way of invoking. So only requirement was that hello world should have been a public class. If hello world was a public class, yes, it could have worked. This could have worked. Fine. Okay, so I'm commenting now. But I'm just mentioning this just to show how to access a, how do we, that we use a class name to access a static member. So your members of a class can be static as well as non-static. So here it's this one here, and we call it also as a only one copy, that is correct. Just like we say static variable are also known as okay. So it's a class variable. We call it as a class variable. Count here is a class variable. Okay. And just like we have a normal methods which are like this, we can have static method. For example, let me have a method. Static method returns the name of the method can be get count. Okay. The difference between a static and a non-static method. Let's check this out. And this can be just saying return the value of. Can I use this dot count or something like this? No. This is only when there is an object. Okay. It will be, you can say rectangle dot count or simply you can use count. Count here means rectangle dot count. Fine, count here would mean, so you are already within the class called rectangle, and therefore when you write count, it actually means rectangle dot count. Okay, static member. Okay, now within this, okay, no, okay, let's try this out. It's a static method, and this is a static method. Within the static method, suppose I wanted to say, oh, let me print the value of length. Yeah, what would happen? Is this going to be valid? Oh, length would have meant, length is an instance variable and therefore it would actually have run this not length, right? Static methods do not have this. Okay. So this is something which is not valid within a static method. Right? So yes, you can't be just saying, I want to use length. Okay, this is not valid. Okay. If you want to have length, you should have some object of rectangle. Length is always related to an object. Right? They are instance variables. Instance variables cannot be used without specifying the object. Right? Earlier, when we were writing length here when length and width are being used, they actually mean this dot length only. So it's not specified without the object. So I'm saying length, but I'm using it inside a variable. So inside an instance method. Okay. So it actually means this dot length here. Fine, it's one and the same. You write length, there's no other ambiguity about length, so you have written it as length. Internally, it has been converted to this dot length. Okay? And we may leave it as length, let's say. So, fine. So, in a static method, you cannot you cannot be using a instance variable. non-static things. And you cannot, okay, see if someone says, oh, let me call the set dimensions. Oh, set dimensions, can it be called without an object? Set dimensions requires an object. It's not a static number. Anything which is not static is dependent on object. As soon as you are using the word static, you are saying this is not about object. Okay? Not related to object. And this is invalid. Set dimensions here is invalid. I just use the word static context. It's a static method here, some static context. Okay? So access to non-static from a static context is not allowed. Okay, fine. Set dimensions is a non-static, cannot be accessed from a static context. Okay, just put it here so that okay, these go as notes, you can see, like the remarks here and the comments. Fine. Okay, so what we have seen so far, a class can have two kinds of variables, instance variables and class variables. Fine, members of a class, instance variables, class variables, fine. Methods and static methods. Static method also known as class methods. And so you can have methods for instance, methods for classes. Static means it's for a class. Okay. And we can have constructors. We can overload constructor. Okay. Fine. Still a few more members are there, but we'll continue about that tomorrow. We'll continue with the other members of a class. Okay. Then there are a couple of things more which we will look at tomorrow. Fine. Okay, so we continue tomorrow. Yeah. And have to save and push it. Okay. So whatever changes I have done today, that will be updated in the code. Okay, so looking at this class called test rectangle and how we were using the rectangle class. Okay, so fine. So line number, line number 10, that is about creating an object. Okay, line 12 I have commented and just to show that yes, this is something which is not allowed. Okay, fine. So if you think that yes, we have this class rectangle and length and width are members of rectangle, so I would like to use it as rectangle.length. No. Length and width, they are instance variables. We call them as instance variables because they exist only if there is an object. Okay, they are part of each object. And every instance has its own copy of the instance variables. Okay, fine. So when you are allocating, see at line 10, when you are creating a new object, at that time, the length and width will come into existence. Right? So there will be one length and width which is part of rectangle created at line 10. There will be another length and width which will be part of rectangle created at line 11. Okay. So these are actually length and whatever instance variables are there, they are only inside the object. Right? So if you try to say rectangle.length, then it is incorrect. Okay, you will have to use it as r1.length, right, which has been which is line 15, We have used r1 dot length. Okay, and then fine. We also have fine. What we have further done is okay. So fine. This is accessing length and width. That is line number 16, 15, and 16. Fine. Okay, how to access? So r1 dot length, that's how you will access. So only on objects you will access the instance variables. Okay, fine. And then we can okay. So this is just again setting the new values for the length and the width. So you can set up the values for the variables like this. It's just about accessing r1 dot length. So r1 dot length can also be set a value. Okay, fine. And then we have we're just trying to print the values of length and width after setting a new value for them. Okay, and later what we have done is we have said okay, r2 dot length. Let's print r2 dot length. Fine. So r1 dot length. Okay, what is r1? Yeah, line number 21, right? This is the line number 21. Okay, it's just to demonstrate. Okay, what we have done here is a string conversion. I think it was done earlier also. Okay, so this is nothing but when I say a string plus an object which I have specified, R2 is referring to an object, right? So when I'm giving this, what will be done? What is there in string concatenation? If the first operand, if any of the two operands is a string, the other operand will be converted into a string. That means the R2 object is to be converted into a string here. Okay, that means pick up the string representation for the object. Okay, fine. So we'll see the output. Yes, there will be something, but it will not be as we would like to have it. Okay, it may not be according to how we what we should be expecting from this. Okay, so we can see what is the output here. So let's see this. Run this code and execute it. Okay, so yeah, we have saved it in the src folder, and that's where we have saved. So we have saved hello.java, fine. And let's compile this java c minus v and dot backslash bin, and the file is rectangle.java. Okay, so when we have compiled, we are saying that yes, in bin we have got the two class files. Right? There is rectangle.class and test rectangle.class. Test rectangle contains our application, so we have to run that from that class, right? Java minus cp class path. Okay, dot backslash bin. Well, that's a place where the classes are available, and what is to be executed is test rectangle. Okay, so if we run this, fine, it is showing r1 is, oh, the first output was r1 is plus, and we say object r1. So what you are seeing in that place, rectangle at the rate and some hexadecimal value, that's a hexadecimal string basically. Okay, this is by default how string conversion happens for object of a class. Okay, fine. We don't like that kind of a conversion. That's one thing. Okay, fine. We would rather have some better information about the rectangle class, about that object. Right? Okay. And then it's printing that initially when we just created the object, the initial value for length and width was 0. Okay, and the next printing where it says length is 7 and 5, that is after we have assigned the values and then printed it again. Okay, R2, yes, we just initially printed it and those values were 0. We have not set a value for the length and width in R2. Okay, so this is about accessing the user instance variable. Okay, fine. Yeah, so as we add okay, let me show okay, fine, we can try to have a look at it in, so you know, when we said see what were the steps, we said r1 equals new rectangle, right? Okay, So when we say R1 equals new rectangle, it's like this. Okay, what's happening is, whoops, this is space for R1. Okay, and when we are saying new rectangle, okay, we have space for R1, R2, and R3. We declare those variables, so there will be space for the variables, which is nothing but just references. Okay, so that they can refer to an object. We say new rectangle, right? So a new rectangle is allocated. Okay, let's think this is one rectangle which has been allocated, and R1 equals new rectangle. When a new rectangle is allocated, space for instance variables is allocated. That means this has got length and this has got the width. Okay. And R1 is referring to such an object. So when we are saying R1 dot length, yes, we are taking this. Same way, now when a new object is allocated, find all numeric values will be set to zeros. That is, the length and width would initially be having a 0 here. Okay, and R2 is, we allocated another object, so that's the rectangle R2, right? And we made it refer from R2. So we allocate object, it was having 0 and 0. Okay, and R2 is referring to this object. Okay, R3 is not yet initialized. Fine. Next step was R1 dot length is equal to 7. So this 0 is replaced with 7. This 0 here is also replaced with a value 5. Okay, length and width we have set to 7 and 5. And then we have printed. So this is what is happening basically. Fine. Clear what exactly is happening in that code here. Okay. And when we are saying, okay, print what is R1 is plus R1. So what was it doing? For this object, the string conversion is done. Okay, fine. We will not like the string conversion which is happening. What is being shown here is it's giving for this object. It is saying, oh, this object is of class called rectangle. Just so see the string conversion. You can see rectangle, and then it puts at the rate, and then there is some hexadecimal value, and we'll try to understand that later. What is the hexadecimal value about? Okay, but this is the way a string conversion happens. A string like this is what is allocated, right? Something like this. Okay, so string which gives us the name of the class for that object, and that would be basically the name of that type. And so classes are types, and this is what was happening. Okay, so let's move on, and so now see, this is fine. This is the structural aspect of our object, right? Length and width, they are nothing but the related to the structure. Whenever an object will be created, this is what will be allocated, right? But another thing which has to be in a class definition is how do you interact with the object of the class? You can define the various kinds of interactions which should be available for the objects of your class. Okay, so the interaction for a rectangle class, right? Your interaction can be, you can be interacting with rectangle class and saying, okay, let me know what is your length. I would like to know the length of that object. I would like to know the width of the object. I would like to know the area of that rectangle. And you may be interested in getting the area. So you may define some interactions like this. What could be the kind of interactions? So here, the type of interactions can be, okay, let's try to list out what we would like to have, okay, as interactions here. So one can be, we will say, okay, if I should be able to get an integer value when I say, so one is, we can say, oh, I want to have a get length. Okay, I'm just giving a method name of the interaction. Fine. Now when I'm interacting with this, okay, let me put another method which will be more useful. You may like to have a method called area. Okay. Now, my question here is, I'm going to have a method called area. Okay. Area is going to be integer value. Okay. So the return type for that method will be the int type. Okay. But my question is, what parameter will area method require? Remember, this is interaction with the object. So what is the method required for? What are the parameters needed for area method? Hmm? You see, this is an object already having its own length and width. Okay, you want to know the area of that object. Fine. So, what do you think should be the parameters in area? I'm not asking about computation. Any inputs to be provided in this interaction? Do you want to give some data to it? The question here is, are you going to be providing that input? We understand that length and width is needed for computing the area. Right? Here it already has its own length and width. Fine. We are not going to say what length and what width. Because it's an object of rectangle, it has its own length and width. For that length and width, I would like to know the area. So here, you should not be having any input parameters. Okay. Fine. So we would like to have method for get length again. So for get length, okay, what is your length? So no inputs to be provided. Return type will be. Right. Similarly, we will have get width. Okay, no inputs to be provided. Return type is going to be okay, same as above. Okay, so we might like to add these interactions, right? And so let's see how we add this in the rectangle class. Right? We would like that these kind of interactions should be available with the object of rectangle. Okay, so let's make that change. So what we were looking at last was something like this. Okay. From that code, like from the main method, so we say, okay, we will have space for R1, R2, R3, and that will be only a reference. So R1, R2, R3 are three references. Okay. And when we are saying new rectangle, it actually initially created an object with zeros. Right? So instance variables are going to be part of the object. So they come into existence only when an object is created. Okay. So before I said new rectangle, there was no length and width at all. Okay. When I say new rectangle, for every object, a length and width is getting allocated. So R1 is referring to one object, R2 is referring to another object. Fine. Initially both are zeros. When we said R1 dot length equal to 7, fine, it has set the value on the first object. Okay. Fine. R1 dot length, R2, R1 dot width. Fine. So those are the things which we have said. So instead of 0, it is replaced with the value 7 and 5. The other thing I think what we are looking at was this that okay, yeah, we were also looking at what are the various interactions we would like to define now. So the next step would be about defining the interaction for the object of a rectangle. Yes. So if we have an object of a rectangle, fine, we should be able to ask what is your length. Okay, interaction with the object will be, let me know your length, let me know your width, right? Let me know your area. Right? So when you are asking for area, you don't have to specify the length and width. Fine. You won't be giving any inputs to the area method because area method is okay. Whatever is your length and width, accordingly you have to return the area. Okay, fine. So let's go to the code and let's try to add these kind of interactions. How do we add this? These interactions will be defined by using methods. So we add method to our class. Okay. So on the top we have the class. Okay. So our class currently has only instance variables. Fine. We are okay. So now we add an interaction. Okay. So this interaction is going to result in an integer value. Let's say we write the area method first. Okay. Let's write the area method. Okay. So what does area return? What should it be? Area of what? Area of this rectangle, right? So area has yeah. So now what is it? What should be this expression here? Yeah. What should I write next? Return. See, one thing is we have variables length and width which are available on object, right? When area method is invoked, it is invoked on some object. When area method is being invoked on an object. So whenever area will be used, okay, we will have that object and we have a keyword in Java called this. So you can say this means the object on which area has been invoked. Right? Within a method, you would like to know, oh, this is method which is being used on some object, right? Area method cannot be used without an object. So it will be something like this. This dot len multiplied by this dot width. Okay. So this means what? On whichever object you are invoking the method. Okay. Okay. So that's how the area method should be. Okay. And there's no length or width as a variable in the area method, right? It is available as this dot length and this dot width. Okay. Fine. Now another thing here is, if I okay, we can compile and run the code and check. Let's first test with the area method. So we have set the values for R1's length and width here. Okay. So after setting the values of length and width, okay, we need not be printing the, okay, we have printed and let's print here system.out.println R1 area is R1 dot area is yes, and let's invoke R1 dot area. Okay, fine. Just similar to what happened with instance variables. Okay, this is for R1. Here also you can understand that, and let me point it out here, that if someone tries like this, rectangle dot area, this is not valid. Okay. Rectangle dot area is not valid. Using rectangle dot area is not a valid thing. Right? Area has to be invoked. The methods are there. You interact with the object of the class. Okay, that is one thing. You always interact with the object. And so you don't use class name dot method. We will be using object dot method. Right here? Okay. So this is not valid. I put a comment. So R1's area, yes, you can print this and let's compile it. So we compile and it's JavaScript as for compilation, and let's now execute. Okay, so we can see R1 dot area is fine 35 less than 2. Okay, so okay. Uh, so let's go back and modify the area method. And in area method, okay, see, you may not specify this dot length. Okay. Even if you don't specify this dot length and this dot width, the compiler is going to make the corrections in there. See, when I am writing in area method, when I am just writing the variable length, first thing it has to look at, oh, is there a variable called length in this method? In area method, do we have any variable by the name length? No, it's not there in the area method. I don't have a local variable or a parameter variable for length. Okay, fine. And therefore, the next thing it does is, okay, I don't find a local variables, but I will not still give an error. I will try to see that yes, oh, we have some variable called length as an instance variable. Oh, then I think what you mean is this dot length. So you may be writing length, but the compiler would make the correction and make it as this dot length. Okay, we'll see where this using this dot length is going to be useful. You might think, oh, when length is working, why should I say this dot length? Okay, so fine, let's keep it as length into width. And so we'll have another case. Yeah, what are the other interaction we would like to add? And we want to have a get length. Okay. And get length can be return this dot length, or rather you may even just say length. Okay, fine. Just similar to the earlier case, here also you should be able to say length. And similarly, when I use get width, and this will be same return, right? Okay, that's fine. Now here, I would like to add another interaction. Okay, we would like to add one more method here. Okay, which allows us to set the dimensions of the rectangle. Okay, so I'll say the method is for setting the dimensions of the rectangle. So I'll have a method called set dimensions. Okay, I have not written the set dimensions. Okay, so our method is set dimensions. It is a method to set the value of the length and width. So this is the method which we will use for specifying what is the length and width to be set. What's the new length and width to be set. Okay, so you might keep parameters for this, input parameters. So you'll say, okay, I will have a int value for the length. I will have another int value for the width. Okay, fine. So when you write a method, yes, you will have a method name, you have a parameter list, but you also need to specify the return type. What will the set dimensions return? This is not for fetching a value. It is just going to take an action where it will change the values of length and width. So we are not going to be returning a value. We have a return type of void. Okay, fine. And then in this, yes, what is the code? What do we write now? We would like to set the length on the object on which a method is invoked, right? We would like to set the length of the object on which the method is invoked to whatever is the first parameter. First parameter is called length. So now, if I just say length, What does it, if I use the variable length here, what does length mean here within this method? It would mean the parameter variable. Okay, this would simply mean the parameter variable. I am interested in using the variable on which set dimensions is called. Set dimensions is called on some rectangle object. Okay, so here we have to use this. Okay, so here it's a must. Okay, this dot width is equal to width. Okay, so fine, clear? The keyword this, it's nothing but the object on which the method is input. Okay, now I'll show you something which has been allowed from Java 11 or something, I think 10 or 11. What they have allowed, okay, just to keep some more clarity to someone who doesn't know, okay. For example, okay, even in set dimensions I can do that. In any of these methods, right, in any of these methods which we have written so far, we could always declare an additional first parameter, okay, a special parameter. We can by the type called rectangle, that's the name of the class, and you can say this comma. You can write like this also to become more clear, to make it more clear. Fine. So if you want, you can put this. See, this first parameter is just nothing but it is known as the receiving parameter. Fine. It's a receiving parameter. Fine. It's the it just is the it's a, we have always, you can't use anything else as the receiving parameter. When you are using the keyword this here, okay, right, this is a keyword of the language. Okay, it is becoming a receiving parameter. Right? The target object which is receiving this method, then the interaction of set dimensions is going to be with a rectangle object, and that is available as a variable called this. You can think, oh, this is like a variable local to this method. So this method has this dot length and this dot width. Okay, fine. We can compile this since we are using a Java version greater than 10. In earlier versions of Java, if you try to use rectangle this as a parameter, that would be a compilation error. Okay, let's try compiling the code. Okay, so let's see. Yeah, it's compiled. Okay, we have used this as a parameter, and okay, let's see how. Since we have defined this set dimensions, we would like to use it. Okay, how we would like to use it? Okay, instead of doing something like r1 dot length is equal to 7 and r1 dot width is equal to 5, okay, we may comment it out, okay, and instead of like this, you might add the method invocation. So you can say, okay, let's have r1 dot set dimensions 7 by 5. Well, that's why we added the method so that we can use it like this. Okay. And basically, let me explain. It's not a good practice to access the variables directly. The way we have done here is not a good practice to do it like this. Right? We don't use r1 dot length normally. Instead, it's a better practice to use methods. Instead of accessing variable like this on an object, we try to use get length, which is a method. Okay. Same way, here also we can use the method called get width. Okay, so we are trying to avoid use of accessing the variables directly. Okay, so later I think here also we have used r1 dot length. Fine, r1's length is, so here don't use. It's not a good practice. Okay, we normally would provide a method to fetch the variable also. Recollect when we talked about the florist example, and we said that diary is there, it should not be available directly to someone. And use it via interaction. So use it through a method. Okay. So we'll say, oh, there is a get length, right? R1 dot get length, and we have got R1 dot get width. So that's how it should be used. Okay. Here again, I think here these two lines also. And we should be using the method. So that is get length and get width. Okay. Fine. Okay, let me just put some comments in this, what we have done. Okay. So we have given one example of a instance variable, and this is example of a method. So a class definition, so far what we have seen, a class can have variable known as instance variable. So examples are length and width. Okay. So they are part of every object. There is a separate copy of length and width for every object. Fine. We have defined method. So if you have got an object of rectangle, with that object you should be able to ask for its area. You should be able to ask for its length. You should be able to ask for its width. You should be able to change the dimensions of the rectangle. Okay. Some people will say, no, we don't want to allow changing dimensions. Once a rectangle is created, it should be as it is. If you want, you create another rectangle for it. Okay, fine. So that's like we say, oh, this object, the object of the class has to be immutable. Okay, we'll see that later. But yes, there will be a requirement where people will say, no, we don't want to allow things like set dimensions to work. Okay. And there are various ways to do that. Okay. So let's compile and run.